Good day, ladies and gentlemen. I welcome you all to Shito's Mathematics Coaching Program. Before the commencement of today's lecture, I urge every one of you to kindly subscribe to my YouTube channel, hit on the bell and the subscribe button in order to get the notifications of my videos anytime I drop them. So, having on the board, we have another topic in further mathematics, that is partial fractions. So, we will be talking and be introducing to us what we really mean by partial fractions, because from my observation, I observed that majority of students, they don't really know what partial fraction actually is. Understand? So, and it is very simple, and it's something that it's something we know, it's something that we're supposed to understand, but maybe due to one or more reasons, so they found it very difficult to get it. But today, I promise I will be introducing us to what exactly is partial fractions. So now, having on the board, we have this expression, that is the left hand side and the right hand side. So now, in order not to waste much of our time, this one is already been solved. That is, if you try to write this left hand side in a single fraction, understand? So when you solve this one further by taking the LCM and so on like that, so you are going to arrive at this right hand side. So now what I really want to bring out from what I have on the board here is just that this right hand side is called what is the question, or is the type of question, the form of question you will be saying, that is algebraic fractions that you'll be saying to resolve, but I will tell you to resolve into partial fractions. So now, like this one here, as we can see, the reverse process of solving this, understand, back to this left hand side, so is what we call resolving of this into partial fraction, or resolving this, that is this single fraction into its components form, that is these are the component form, or they can say you should decompose this, that is this single is in form of this now, that is single. So now to decompose it is to try to break it to its simplest form, that is, so that it will be in form of this. Understand? So therefore you decompose this. So from here back to this is what we call partial fraction. Are you getting it? So there are some cases. We have 3 to 4 cases that we need to understand before we can solve any problem on this. And today we'll be looking at just one, that is the one with linear factor. The one with linear factor, when your denominator is in the form of linear factor. So that's the first case. And in order to solve problem here, you look at the first thing you are going to look at, if your denominator is not in factorized form, so you need to write it in a factored form, that is something like x plus a or x plus b. You should see that if you try to multiply this one and this one together, so you have this in form of this I have here. Understand? When you try to open the bracket. So now, but if you are given, like this example, you can see this one is not, that is the denominator is not in a factorized form, so you need to factorize this one first. That's the first thing you are going to do. Now the second thing you are going to do is that, looking at this, you need to observe very well that look at the numerator and the denominator. You now look at the highest degree of x. When I mean degree, I mean power of x. The highest degree of x here must be at least 1 less than the highest degree of x of this denominator. So if you look at this one, you can see that the highest degree of x here is 1. Why the highest degree of what of s here is what at the denominator is what is 2. Therefore, so when you have something like this, when you have a fraction like this, so this can actually be what be resolved into partial fractions. So maybe in case you now found that the highest degree of the denominator is equal to the, let's say we have the highest power to be 2 here and also the highest power to be 2 here, also you can say they are the same thing. Or you can see that the highest degree of the numerator is what is 3 and this one is 2. You can see that the denominator is what is now higher than this. Definitely what you need to do is to divide this numerator, that the one that is what that is upper one, divide it by the one that is below, so that you have what you have this degree to be what to be reduced, the higher degree to be reduced, that it will be reduced so that it will be less, at least 1 less than the highest degree of the denominator. I don't know, are you getting what I'm saying now? So that after that, so you'll be able to go ahead and solve further. So now from here, let's say you want to solve this one in order to bring out something, because I told you this one is already been solved. If you try to solve this one, because you want to solve this one back to this and it is already been solved, so I just want to bring out this so that you know that whether what we have said earlier is what is actually correct or not. So now this one, we try to solve this. We have 4x minus 5 divided by x squared minus x minus 2. From what I told you, in order to solve this one, your denominator has to be factorized. Therefore, we don't need to disturb ourselves for that. This is factorized into this, that is x minus 2, x plus 1. So if you look at this one now, the form of this denominator is what is linear. I told you something in form of this. So this is linear. So if you have linear factor like that, so to resolve this in form of what, to resolve this one into partial fractions, definitely you have a over, this will be in form of what, x minus 2, that is a, you pick, a is a constant attached with this one, plus b attached to the second factor. Are you getting this now? So now our problem now is to get way to solve a and b, because a and b are the what are the what we are looking for now. Understand? So they are the constant that we must know here. So we try to look out for them. So now from here, you try to solve this one for that. If you try to solve this one for that, you take the LCM. The LCM of this and this is same thing as what, x minus 2, x plus 1. Are you getting this now? So now if you want to take this one to a single form of fraction, so what do? This one we cancel this, remaining this one we have a x plus 1 plus this, we cancel this, remaining this one we have b multiplied by x minus 2, which is equal to, you can as well write this one further as what, as this x minus 2 x plus 1. So now try to solve this one further. You can see that both sides are having the same denominator. You can see they are the same thing. So to clear this fraction, therefore you try to multiply both sides by the LCM, because the LCM of this equation is this one and this. So now try to multiply through by this and this. So actually this will result to 4x minus 5 equals to ax plus 1 plus b x minus 2. So we have what we have equation star. So now this is what we are going to look at. So from here we have what, we have two ways of solving, of getting this a. Understand? So we have cover up method, I mean the cover up rule method, and at the same time by comparison method. So from here I will be choosing the shortest one, which is what, by cover up rule method. So now using cover up rule method, is just that here, since we are looking for a, you you try to eliminate one part first and get one. Understand? So how are we going to do that now? From here, you look for the value, that is, you put the value of x here that will make this a to be 0, then you solve for this. Then you now do for this one also, you look for the value of x that will make this b be 0, then you solve for a. So now I want to make this a to be 0. Definitely I'll be putting x equals to what? -1, because if I put x equals to -1 here, we have -1 plus 1, so everything will be 0. Therefore we have what? In star. Put this in what? In equation star. Definitely we are going to have 4 into -1 minus 5 equals to a into -1 plus 1, then plus b into -1 minus 2, we have -3. Are you getting what I'm saying? Now from here, 4 times this one, we have -4 minus 5 equals to this one returns to 0, then we have -3b. So from here, so what are we going to have here? You can see that -4 minus 5 is what? Is -9 equals to -3b. Automatically, therefore we have our b to be equals to, because you divide through by -3 here. When dividing through by -3 here, therefore you have what? -3 minus 3. This one you cancel this, so you have b to be equals to what? B to be equals to 3. Are you getting it now? So now it means we have already gotten the value of what? Value of b. So now you do the same thing. You put what? You put x equals to 2 here. That is, you can see that if you put x equals to 2 here, automatically 2 minus 2 0. 0 times b, if you have b, definitely you solve for a. So in what? In star again. So we have what? 4 into 2 minus 5 equals to what? A 2 plus 1 plus b into bracket 2. You have what? B into 2 minus 2, and we have from here, we have 4 times 2, we have 8, 5 equals to a 2 plus, we have 3 or 3a, and this one turns to 0 automatically. So from here you can see that 8 minus 5 gives what? Gives 3 equals to 3a. So now to get the value of a here, you see that we try to divide through by what? By 3. So divided through by 3, automatically we have our a to be what? To be 1. So now if you look at it very well, we have gotten our two constants, a and b, to be 1 and 3 respectively. So if you look at this now, you now come back to this place, that is this equation, this one, come back to that, then put back the value of what? Of a and b. You can see that a is what? Is 1, and the 1 is here. Also the b that we got is what? Is 3, and you can see the b is here. So you can see that definitely resolving this or decomposing this into partial fraction will actually give us what we have on the left hand side, and that is how it's being solved. So now this is the simplest, because we are dealing with the what? We are dealing with the denominator with linear factors. So in the next videos we'll be talking about the denominator with repeated factors. So how are we going to solve it? But the issue is that the basic understanding is actually needed here. So now if you actually understand this one very well, so you'll be able to go further in the next types of solving that we have concerning this topic. So now that is how it is being solved. As we just solve it, if you think maybe you have 1 or 2 questions to ask, so you do not hesitate to ask me, and I promise I will give you the best answer you deserve. So now that is how it is being solved, and this is the end of today's lecture. So I wish you best of luck and have a wonderful day. Thanks.